Welcome everybody to today's webinar, Digitalization in Machining, live from our new technology center here in Kaufbeuren. My name is Markus Preuss. I'm head of product management tool control at pro-micron, and I will lead you through today's online seminar. Before we start with today's lecture, we as pro-micron would like to introduce ourselves and our products of the tool control center with a short video.
Pro-micron ist ein Unternehmen, was sich auf die Herstellung und Entwicklung von drahtlosen Sensorsystemen fokussiert hat, aber eben nicht nur dem System, sondern dem Algorithmus der Software, alles was man damit machen kann, zum Beispiel eben auch in Maschinen. Wir sind derzeit 44 Mitarbeiter, davon 19 Ingenieure. Wir wachsen sowohl in der Produktion als auch bei den Ingenieuren, um das Potenzial, was wir sehen, zu heben. Wir haben in 2019 mit 247.000 Mitarbeitern in der Metallbearbeitung über 100 Milliarden Umsatz als Gesellschaft in Deutschland erwirtschaftet. Wir halten es jetzt für ganz besonders wichtig, dass die Digitalisierungslösungen hier Fuß fassen, um diese Wettbewerbsfähigkeit, die wir bisher haben, auch weiterhin auszubauen. Und Spike ist unser Beitrag dazu.
Die Spindel ist Teil der Werkzeugmaschine, der eigentliche Antrieb. Wenn man die Kräfte in der Bearbeitung erfassen kann an der Spindel, dann kann man den Prozess analysieren, man kann den Werkzeugzustand analysieren, man kann enorm viel Informationen aus dem Prozess herausbekommen, um dann Prozesse effektiver zu steuern, effektiver zu fahren, um Fehler zu erkennen und so weiter. Und das ist das, was wir mit unserem Spike-System gemacht haben. Die Informationen werden sofort übermittelt und auch visualisiert. Er kann sehen, wenn das Werkzeug verschlissen ist oder eben wenn es noch nicht verschlissen ist. Das heißt, er kann das Werkzeug so lange fahren, bis es eben wirklich seine Verschleißgrenze erreicht und nicht einfach wie bisher nach 1000 Teilen immer wechselt.
Bisher war es so, man hat mit der Werkzeugmaschine eine Bearbeitung durchgeführt und danach kam ein Qualitätssicherungsprozess. Das war ein zusätzlicher Schritt mit Logistik dazwischen, mit manuellen Schritten dazwischen. Das zu integrieren ermöglicht eine deutlich höhere Automation, ja, steigert die Effizienz. Das ist Hochtechnologie, die wir in Deutschland einsetzen.
Wir möchten mit Spike den Standard setzen in der digitalen Zerspannung,
weil wir die Überwachung von Zerspannprozessen in ein neues Level heben.
So, I hope you get a little impression behind the scenes of pro-micron. And before we'll start, I want to like to use our agenda to briefly introduce you to what you can expect today. We will start with the cost drivers of the general value chain. After we go to big data with pros and cons. Afterwards, we will go into the data concept of pro-micron with the Spike technology, the decisions directly on the machine, the Spike map, outlook to our AI, and after we can do a Q&A. So as I already mentioned, at the end of the webinar, we still have enough time to answer your questions. So please switch your mic off and we will go at this point at the end. So far, so good. Then let's start with the classic value chain in machining. As mentioned in the video by Mr. Lisicki, the Vice President at Grob, and also like we can see on the slide, the downstream quality costs are a major cost factor in mechanical engineering. So the cost after or behind the value adding processes, like could be seen here. And the later an error is detected, the more expensive this error becomes. So the high quality costs are a big cost factor. However, this acknowledgement is not new, but that is the reason why our machines are getting smarter and why we add more and more sensors into our machines. Today's machines consist of a large number of sensors, both as a standard or as optionally selectable. Here it's often difficult to decide which sensors or options are the right ones. In any case, sensors are the basic building block for the path of digitalization and the big data approach. But what do we do with this huge amount of data and this multitude of sensors? With intelligent algorithm, we filter the data according to our requirements. But often, only a small fraction of the data is needed for one specific requirement. As an example, for the quality forecast of a part. So the situation is, big data volume is needed, mainly downstream analysis of data, and data specialists are needed. But let's go back one more step and have a look on the big data concept in a fundamental way. On the left-hand side, we can see the advantages of big data, and the advantages of big data definitely predominate. Chances for better decisions, increase of productivity, to reduce cost, improve the service efforts, more flexibility, structured data storage. But for the disadvantages, mostly and especially in Europe, the point of security brings a huge discussion with it. It is not the security itself, mainly it's an internal political decision in a company. Everybody and everyone wants to produce big data, but nobody is ready to share the data. So the other disadvantages would be big data volume. We need experts, so data analyze experts, or we need a quality of data because it could fluctuate. But the fact is, we have to change of mindset in machining industry is needed. So now I want to show you our idea of the smart data approach. So it starts at the end, but I just want to give you a quick overview, and I just wanted to let the video speak for itself. Later on, we will go much more in detail into this solution. So it was just a quick jump into our product. So in a summary, what is the pro-micron spike map? It's a plug and play solution, so very easy to handle. Plug and play at the machine, very easy. A 100% quality control, next level process monitoring. We can do machine reaction. We have a documentation, and that's till to the down to the smallest forces. The external data stream is prepared to connect, and we are ready when you say yes, we get the security. But what makes our approach so different? We as pro-micron, or our pro-micron philosophy, means the further from the machine, the less quantity of data, but the more quality of data. So data pre-processing. We mainly focus on efficiency and response. With response, I think response with the machine and machine response, and to create some actions. With our data hub, the big data approach is still possible, but just where it's needed. So we got our spike sensors on one hand side, spike mobile and spike and spindle. We got the radio connection to send the raw data of bending moment, torsion, axial force. And here we get very nice and clever. So that's the brain of our tool control center filters and algorithm to calculate numbers which the machine could read. So we get here like an ample signal. So we get red, yellow, and green signals, which are very easy to handle, and we get values. So the pro-micron spike facility, raw data directly at the action point, real-time algorithm decisions and reactions directly on the machine, and no operational specialist is required. But let's see how big spike data are. When we look at our spike mobile and look at axial force, torsion, and bending moment for the 4 channels with 2,500 hard sampling rate, we get per minute 1.6 megabit of data. Per day, 2.4 gigabytes. Per week, 16.8. And per year, we got more than 900 gigabyte of data. And now, imagine the impact for sensor systems with temperates above 20,000 hertz. Or even better, imagine you got more than one machine in your machine hub. So back to our spike system. By using an example from aerospace, one of the big blisks needs about 70 hours operation time. And in the 70 hours, we generate about 7 GB data. This is about 10 CD-ROM of 700 megabyte. Let's compare a few of the most common sensors in another way. Here we got our spike sensor technology at direct measurements. We got a spike mobile as retrofit on all the machines as possible. We get different sensitivity classes, so we can use it from huge tools to the smallest tools or the finishing processes. We got our spike and spindle solution, which could be ordered at Grobe or DMG, which is a very small sensor in the spindle nose, and in the spindle nose where you can see most of the data. As next, we have an indirect load measurement system by the spindle, for example, spindle load, or we have a direct status measurement of vibration. The data which we can see are axial force, torsion, bending moment, temperature. But yeah, we see different things. We see maybe vibrations, we see bending moment. But the use case in serial production, in monitoring, in quality, you don't want to know a bending moment. You want to know a value of chattering. You want to know a value of quality. So what we want to show with this slide is the general networking of all data through pro-micron 2 control. With the data hub, you can combine all these sensors. It doesn't matter which sensor you use or which sensor you need. Options of machine integration. We get different kinds of machine integration. On the left side, we see our sensors. We get the receiving unit, and this receiving unit could be connected to the machine with different interfaces. It doesn't matter if it's an analog, digital, Profibus, or Ethernet connection. The best and most sensible solution for you can just be determined in a joint conversation. Don't hesitate to contact us to discuss your individual use case with our application engineers. We'll be happy to advise you. You will receive further information tomorrow in our lecture number 2. My colleague Leonard Riley will do this tomorrow. And I think the English point is tomorrow, I think at about 16 o'clock. But you will find in the brochure at which time exactly. The English version will be tomorrow. Oh, here I put it down. 2:15 p.m. A small note. I'm sorry. So, but enough of raw data and theoretical data concepts. What benefits can we achieve for the use case of inline quality control? With our patented spike polar, we can see more than just a vibration or an increase of force. Here, for example, if one of the cutting fluids get a small breakout or something like this, we can see each cutting fluid, and so we can detect something like this. But how that works in machine connection. Our concept of smart data strategy is when we look at our raw data, we get a spike polar time frame of, for example, 1,000 points. So out of the raw data, we get 1,000 points. Okay, now we got this 1,000 points, and we got intelligent filter options to reduce the spike polar as we needed for this solution. So here, for example, we reduce the 1,000 points to 50 points. After, we got another intelligent algorithm which calculates a value between 0 and 100. So we got one value for one benefit. And do you think a machine can read this value much better than the raw data? Of course it can. And that's the reason, and that's the way how we do decisions and reactions directly at the machine. But let me show you this strategy with two concrete examples. Example number one, the KPI for cutting edge breakage and concentricity, so run out errors. We can see a new tool, a slightly worn or a highly worn, one cutting fluid. So we prepared this cutting fluid. And here you can see this one fluid. At the beginning, everything is very symmetrical. So yeah, we get a very high level at the blue one. But after this slightly worn one cutting fluid, you can see there is a change in our spike polar, and that's what our value calculates out. And if you get a highly worn tool, you can see that the asymmetry is very, very bad. And so here you can do a decision. The decision is, okay, I have to change the tool, so you can do the reaction, change sister tool. Another example is when we look at our raw data of bending moment, we can see here for the people which know our spike system, yeah, with the raw data, you can see, for example, the amplitude. You can think about vibrations. So when there's no chattering, the amplitude is a bit, or when you get strong chattering, the amplitude is higher than with no chattering. So, but what do most of the machines do, or what does the spindle load monitoring do? They're filtering the data. And that's what you can see here with the red line. So filtering the data means, yeah, I can see more, I can see smaller tools. But when we look at this small red line, we can see no difference between no chattering and strong chattering. So now I want to show you our chatter KPI. So how the chatter KPI will look in the different situations. When we have no chattering, here we can see chatter KPI 0 to 100. Here we got a level of 0. When we have a strong chattering, here we have a level of 100. And that's what we thought I told you before. We can do a decision or a reaction. Doesn't matter how high the bending moment is in this situation. If you want to react on chattering, we can give you the chatter KPI and can tell you, yes, it's chattering or not. The network of data stream. To understand a bit more, I want to give you an insight to our software architecture. On the left, there's our control center, our tool control center. That's the brain and our know-how and the intelligence of our tool control center. So here the data is processed almost in real time. The input side, we got our spike sensors. You can put spindle engine, you can do machine X positions, or you can add on many other sensors. All the data goes through our Spike Data Hub in real time, and this will be the connection. And then it's on you if you want to store data. But for you as an end user, you primarily are interested in the output. So reactions, external data streams, quality reports, and much more. So linked to the data of Spike, I want to present you use case number 1 for today. We are now slowly coming to the climax of our today's talk and our Spike map. So the idea is to synchronize the measurement data with the X position. So to create a kind of a digital twin from our solution is called Spike map. So in use case number 1, for the quality requirements of an aerospace machines, we have the requirements surface quality, definitely. Surface is very, very important. So we want to detect chatter marks or unbroken cutting edge. Aerospace quality reports. Each part should be reported. Each part, you should know how big or how good the quality is of your part. We need an easy handling and visualization, and definitely you want reactions into the machine. And that's all together with a plug-and-play solution. Now, but enough of the words. Please join me in welcoming our application engineer and product manager, Dirk. We will go into the camera. Like you can see now, here next to me, our machine.
Welcome to the Tech Center in Kaufbeuren. So today we show you a machining process of an example of an blisk, and we can switch the camera to the machining space. So Tim, yes. So on the left top window, you see me in front of the milling machine. On the left bottom, you see the machining space. And on the right side, you see the Spike map. At this machining process, we use a workpiece of aluminium and has a spindle speed of 12,000 RPM and a feed rate of 1,000 millimeter per minute. So this is our example for this session today.
So thank you, Dirk. I think it's very nice to have such a tech center here in Kaufbeuren. It's also for you, it's very nice if you got, for example, a machining operation which you say, okay, it's not, we got a few problems with it. Maybe you can talk with our application engineers. Like you can see, we have all the cameras looking into our machine. So maybe we can do the one or other use case together with you from Kaufbeuren. You can send us your workpiece and your tools maybe, and we can do the test here directly in the machine. And via the internet, we can show you Spike data, we can show you the Spike map, we can show you process optimization. All of this is possible here from our new tech center. And you can see behind Dirk, we also got now a new grobe machine. We are very happy also to have such a machine park here in Kaufbeuren. So thank you, Dirk. And we just wanted to show you the whole process of the part, and because of this, not the monitor switched off, but I will talk to you so far. After the monitor will start again, I will show you the whole machining operation of the Spike or of the product which you've seen on the machine in a video, because we did a summary of the video, because the machine runtime of this part would be at about 25 minutes, and so we compromised this 25 minutes in a video of about 3 minutes, so you can see all the data, and you can see the spike map, and you can see the machine runtime. Let's start with the roughing. Here's a diameter 25 head cutter. It's very easy to see that there's more material removed on the left side. I will put my pointer on again to show you. So here we can see this red area. There's more material on the left side, like we can see right now, than on the other side. Here we got the first part, so above the part, and in a few seconds we will change to the second process. The second process, like we've seen in our machine before, the second process is with a 12 millimeter ball end mill, so it's the semi-finish process. Here you can see that's exactly the same process we've seen before, but here I want to see, here you will see exactly at this position, you can see very well how the wings and the geometry of the component, large amounts of force arrays, especially on the side. And that depends on the geometrical conditions of our part. So you can see very clear here. We show the bending moment of the part. So there's so far no KPI what we show here, but we are actually developing also this, so you can change between the bending moment and all the different KPIs. Actually, just you can, after processing, you can calculate the KPIs located on the part. So the next part is the third, or the next process is the third process. It's our finishing process with another 12 millimeter ball mill. And there, I have to tell you, we are milling aluminium, and we got an infeed of 0.1 millimeter. Such fine processing cannot be represented with spindle current alone. That is why we use our Spike Mobile with our sensitivity class A. So even for such small processes and for such small infeeds, we got very, very good force measurement and visualization. The goal behind the spike map is an after process decision with yes or no, or through the process decision, okay, part okay or not okay. So if there is an event, we want maybe a machine reaction. When the component process the first time, for example, the prototype, the operator receives information about the NC block number additional to the data by clicking on the spike map. So if you can locate some problems, if you say, okay, hey, I got some problems here in this area, you can click on them, and our spike map will show you the NC block number, and so you know exactly where in your NC code you have to change something. Or further quality controls escape or can take place in a targeted manner, only at necessary points. What entails a great time and cost saving. So the benefits of the spike map in aerospace, mainly to be mentioned, is the documentation. We talked to a few of our aerospace manufacturer, and most of them told us that the documentation is, and the quality reports are very important for them. But there are also other benefits for in-process surface quality control, in-process monitoring for sporadic and systematic errors, machine reactions, position-orientated visualization or connectability of our spike data into your data lake or something else. So let's have a look at another use case, die and mold. When we look at the workpiece, here we get the same story. Too much material removed, the higher the forces are, we get a red. You can see the digital twin or our spike map, you get a red highlighted area. If you get too less material removed, you get a blue or green area. So to reduce cost or to quality, the benefits of the spike map at die and mold are again the same, but as Foke told us, the machine reaction is the most important thing. So select sister tool, machine stop, or even again, documentation. But now let's transit to the partners and references. Here you get a briefly insight into a few of our end users who have already introduced Spike in their series or are actually in the process of integrating Spike into their series. For example, Bosch. Now more than 50 machines worldwide in 24/7 production monitor a deburring process with our Spike mobile, day by day. Or for example, Ceratizid. Tomorrow there will be also a webinar of Ceratizid. You should jump into tomorrow. They will present you an automatic tool, radius correction inline in the machine, in the process, in the production of an M2 thread. So with a thread milling. And also, for example, Striker should be mentioned, with whom we conducted a short interview. So, Mr. Markus Böcher, the manager pilot line advantaged operations. Where do you think the trend or tasks in machining will go? Can Spike help you?
For me, it's all about lean production. That means about reducing any kind of waste. It doesn't matter if it's production time, reject cost, not adding value work, or downtime. If such new technologies help us, this is exactly what we are looking for.
So, like I mentioned at the beginning, the downstream quality costs are a major cost factor in mechanical engineering. The later an error is detected, the more expensive this error becomes. And now let's have a look how this situation will change by using our TCC, our Tool Control Center. The inline quality costs can significantly reduce the downstream costs by our inline process quality control. So the quality cost could drastically be reduced. And now let's have a short look into the future together by looking at one of our machine learning approaches. So outlook of AI. Just to mention, we got different labels for a drilling process. So for example, we say, yeah, okay, there is no error. So it's a good process, quality is good, tool load is good, we get a stable process. But we have a signal pattern trained for labeled for tool wear, for tapping error, for drill cores, for chip clamped, or for some other errors. And we trained the labels 100 times. After 100 trainings, we did 50 good trainings, and of each label, we did 1 bad training. after 100 processes, the idea was we had an accuracy of 95% after 100 trainings. Yes, it was a good process or it was a bad process. After 100 trainings, still after 100 trainings, the differentiation was at 69%, which of the special errors it was. So there has to be mentioned, with an increase of the amount of learned data, we will increase the prediction accuracy. The next step afterwards will be the transferability to other or similar processes, or for example, to different tool diameters. So much from my side. I want to say thank you to all our partners, to all the companies which help us to have such a good event like the DMAP. And now we got time. If you have we have some time left for your questions. And if you get some questions, you can write them into the chat. My colleague will read them.
Markus, I have a question. Can you give us again a rough idea of how big were the forces in the finishing operation with the blisk you have machined? Which force level is Spike measuring?
The biggest force in this aluminium measurement was at about 1.2 Newton meters. And let's talk, it's bending moment. So it's not the torsion moment like a spindle engine, for example. So because it's aluminium and we got very small forces for that. So 1.2 Newton meter bending moment. When we calculate with a leverage of 150 millimeter, for example, you can also calculate out the force bending moment divided by lever arm.
Okay, thank you. Interesting, pretty small, I would say.
Of course, it's very small. That's the idea behind Spike. We don't want to have a Spike mobile like you can see here for every process. Just use a Spike mobile as a sensitive tool where you need it. If the spindle load is okay, or if other sensors give you the information, there's no problem for us. We got the tool control center, so we can also put the data of another sensor in our tool control center and do exactly the Spike map with other sensor data or with other informations.
One question from China. It's a powerful feature what we have with Spike Map. When is it available? That's the question.
That's the same question you ask me all the time. So the Spike map, hopefully, and actually planned, we will start quotations next month or end of this month, and we think we start delivery mid of this year, so maybe beginning of July. There's the planned first rollout. We are still thinking about if we want to make a beta test phase. So maybe we will choose 10 customers for 2 months, which can then work together with us. But definitely this year, and the first plan is actually mid of this year. It will be available.
Okay, thank you. So if someone is interested in to have Spike Map now, he can ask for a quotation already.
He can ask for a quotation, but we need 1 or 2. I think now we get during the next 2 weeks we will be able to do the quotations.
Okay. Then there is a question from Canada. He's asking, could you please give us an insight with more details about raw data analysis into the machine tools and how KPI are calculated outside the machine tool? Thanks.
I think I'm not allowed to give all the information out because a few of this algorithm and filters are exactly that what our Spike know-how is. But I think, can you read again the first part of the question? I think there was some information I can give.
Yeah, how do we get the raw data analysis into the machine and into the machine?
Yeah, with our Spike 2 control center. So you can imagine you have no sensor. So let's start with the spindle load. We can read out with a small IPC. We can read out the spindle engine and can plot the spindle engine as a digital twin. If you say okay, and if you then now see that's not sensitive enough, we can add our Spike mobile tool holders. So you charge them; they're wireless. You put them into your machine with your tool, and we get a receiving unit, which will be installed at the machine. And you just have the same IPC, the same software, and they can communicate to each other. And on the IPC, there's our brain. So there will be the calculation, the algorithm, the filtering, the data, and there will be also all the raw data. So if you say we want all the raw data, we can send you the raw data. But mostly, because big data are so big, mostly not all the big data are needed, and that's why we filter exactly on the machine.
Thank you. I think that was good.